Alright students, for our second day of instruction, we're going to talk about definite integrals. Before we looked at what are called indefinite integrals, so now it makes sense that we talk about definite integrals. If you've been watching the Khan Academy videos that I've been linking you to, we know that with an integral we can find the area under a curve from a to b. So if we have some function f of x from a to b, we can find the area here by performing what's called the definite integral from a to b of f of x dx. And that is equal to the area. There's one extremely important rule. Your a must be less than b. So if I had a equals 3 and b equals 5, you can see your lower number here is on the bottom. And let's say I had negatives. Let's say I had negative 6. So this would have to be greater than it. Okay, negative 6 is a larger negative, which makes it less than negative 4. So let's take a look at what all of these symbols mean. How do we actually carry out a definite integral? Now that we know how to write it, how do we do it? Well, all you do is you're going to separate the integration. You're going to integrate the larger number first, negative 4, and subtract the integral from the smaller number. So as one clean formula, you can write in your notebook, the integral from a to b of f of x equals the integral of f of b minus the integral of f of a. So let's take a look at an example. Suppose I have the curve f of x equals 3x squared. And I want to find the area from 1 to 2. We have my lower boundary with 1 and my higher boundary with 2. So that means I'm going to want the indefinite integral, we get my lower numbers on top, from 1 to 2 of f of x dx. That's the integral from 1 to 2 of 3x squared dx. We're going to use the same rule that we used before. So I take my exponent and I add 1. So I'm going to have 3x cubed. And I'm going to divide by my new exponent, so 3. My dx becomes plus c. Now we haven't used our 1 and our 2 yet, so we're going to save them, keep them at hand so we don't forget about them. At the end of the function, you're going to write a big, tall vertical bar. At the bottom, write your 1. At the top, you write your 2. Now we can simplify our function. Get x cubed plus c. Again, we haven't used 1 and 2 yet, so we're just going to plug those in. Oh, nope, small number on the bottom. 1 and 2. And now we want to plug them in. So I'm going to plug in my 2 first, and then I'm going to subtract, plugging in my 1. And that will give me 8 plus c minus 1 minus c. You realize that our c's are just going to cancel out. We have plus a c and then minus a c, and they're going to cancel out. And that happens every time you do an indefinite integral. Your plus c's are just going to disappear. And all you're going to be left with is 7. So let's take a look at one more example to see what we're really in for with our definite integrals. So here we have the definite integral of 3x minus 6 dx. So we're going to start off by taking the integration. So we're going to have 3x, we're going to add 1, so that's become squared, and we're going to divide by our new exponent. If you remember the rule, when we have just a constant and we integrate it, we just get an x on the end, and we're going to do plus c. We haven't used our numbers yet. I'm just going to write them over here so we're ready to use them. So now I'm ready to plug in. So I have 3 halves of x squared minus 6x from 12 to 15. Again, my plus c's are going to cancel in the long run, so I'm just going to get rid of them now. So I have 3 halves, 15 squared, minus 6 times 15, minus 3 halves, 12 squared, minus 6 times 12. I'm going to take my time with this algebra and work it out piece by piece. So that's going to be 3 halves of 225 minus 6 times 15 is 90 minus, now remember we're going to have a minus, so eventually we're going to have to distribute. So it's going to be minus 3 halves times 144. So this is where that minus and minus came in, minus a minus. So we get plus 6 times 12, which is 72. Oop, that's got really fat. 72. At this point, I'm just going to go ahead and use my calculator on my phone to calculate this fairly quickly. After plugging that into a calculator, you just get 103.5. That's all the videos for this lesson. There's some practice for you assignments attached. You need those completed by Friday at 2:30. Thank you very much.